When we look at the results of an experiment, we're often interested in whether or not the treatments that we've used during the experiment produce a significant effect on whatever we're trying to measure. So what we do within the experiment is we record multiple times from a particular outcome. This might be the number of cells, the number of insects, or the expression of a particular gene. And that gives us what we call a sample. The sample allows us to make inferences using statistics. What we then need to do is compare that sample of changed values against some kind of null model. The null model can be a control where we run the same experiment but without whatever treatment we've applied, or it can be a theoretical null model like a normal distribution in the case of testing for normality. So what we would do is we would build up a series of different values and compare two distributions to see whether or not they are statistically significant. And what you can think about is that these are going to be two frequency histograms. So we have frequency on our y-axis and the particular value of whatever it is that we're measuring on our x-axis. We might have one distribution, which is our treatment. And so we might find that this frequency histogram looks something like this. And we want to compare it against a control variable which might look something like this. Now what we're interested in is whether or not the control treatment, so this is here, is significantly different from the treatment here. And the way that we can do that is using tests that compare either the median or the mean of these two distributions. So if you think about the average value for each of these distributions might be something like this, might be something like this, and what we need to do is figure out whether or not the differences between these two central measures is statistically significant. And we can do that using a t-test. So what a t-test does is it compares whether the values within each of the distributions are likely to have been drawn from the same distribution. The way that a t-test works is by taking into account two key aspects of these two frequency distributions. The first is the difference in the means of the distributions, very simple to understand, that's the blue arrow that I've drawn on here. But the second is the variability within each of the distributions. So here we have in green the variability in the control treatment, and in yellow we have the variability in our treatment, where we've applied our treatment. And all the t-test does is look at the ratio of the difference in means against the variability in the distributions. And that's a combination of both of these distributions. And so the output is effectively just a ratio of those two. And obviously if the difference in the means is far greater than the variability, that means that what you've got is two tightly controlled distributions. So I'll just draw those quickly up here. So that might be, so difference in means very large, like this. But if you have a difference in means that's small relative to the difference, to the variability rather, then that might be something more like this, where the two distributions overlap, and so the result is that there's no statistically significant difference. So on the left-hand side, we're likely to see p less than 0.05. On the right-hand side, we're more likely to see p greater than 0.05. So this is how the t-test works, and that's conceptually how you can use it to test the effects of a particular treatment on your outcome variable of choice.